Hey, welcome back everybody to my object-oriented programming course. Today we're going to talk about recursion. Recursion. Now this is a topic that is usually saved for data structures, but I am going to go over the fundamentals of recursion here. And then the other thing I do want to mention is that if you're going to dive further into computer science, you should understand recursion, because a lot of problems that they ask you about to solve in interviews are going to involve recursion, which can lead to a dynamic programming solution. So, and I know a good tutorial, which I will put up in this video, from another channel, which is I thought it was great, but it uses JavaScript, doesn't use Java. But you can probably translate it to Java or any other language. But a great tutorial. They go into recursion and also dynamic programming, if that's something that you're interested in. Okay, so let's talk about what recursion is. So recursion allows you to call a function over and over and over again. So usually when you're trying to program trying to accomplish a task, you want to divide it into subtasks, right? So you'll have a function that does X, then you have another function that does Y, and so on. So with recursion, it's just another tool that you can use to efficiently solve a problem. Now, you can get yourself in trouble if you use recursion in terms of finding every solution to use recursion, meaning that every problem that you're going to tackle, you're going to think of recursion as the first tool that you're going to use. That's a wrong way to think about it. Some problems lend themselves to recursion, some don't. Okay, and you'll learn to recognize that as you go through in terms of going through recursive problems. Now, having said that, the way that I like to go over or introduce recursion to a programming student is first to understand the recursive process. So what I'm going to do is I'm going to lay out the code, the problem, and what it's going to accomplish, and I'm going to give you the solution right away. I'm not going to expect you to write a recursive function. And then you can use that to build your tool set in writing your own recursive solution. Okay? So this first problem we're going to talk about is it lends itself to recursion. So let's say we had an arbitrary input where if they enter more than one digit, you want to print it out in a vertical fashion. So I'll give you an example. So let's say if we had the input 3, then your output is going to be 3, right? If we had the input 1, 2, okay, we're going to write that vertically. So we're going to have a 1, a new line, and then a 2. Okay, and then if we have 1, 2, 3, then we'd have vertically again, so 1, new line, 2, new line, and then 3. Okay, so we're going to write a function or a method that is going to be called write vertical. Okay, and I'm telling you already that this function is going to lend itself to recursion. Okay, so let's start there. I mean, I'm not expecting you to figure this out on your own, because we are still trying to first learn Java and learn all the OOP principles. So I'm already telling you that this problem itself lends itself to recursion. Then you can look at the Fibonacci examples and all that, but this is just a simple example that we can use. Okay, so if you notice on the left, the input here is an integer, right? It could be 3, 1, 2, 1, 2, 3, 1, 2, 3, 4. And ordering doesn't matter. I just did it for simplicity's sake. So that if we call write vertical, okay, and we call it with with n equal to 3, then we're going to get this, right? If we call it with n equal to 12, right, then we're going to get this, right? And then finally, if we do 1, 2, 3, then we're going to get that. Okay, so again, I'm laying out the framework of the understanding of this problem and how we're going to approach it. Okay, and we're laying out just the signature of the method. Okay, great. Now, what we want to do is we want to write this in terms of in a recursive fashion. Okay. Now, I'm going to give you the function already. I'm not going to go into each step of how I thought of the recursive method because that's something that we can tackle on in future lectures. Okay, it really lends itself more to a data structures course, and I'm not really here to teach you algorithms. I'm giving you a little bit of a taste of it, but I'm not really here to go into the explanation of how we came to the solution. Okay, I just want you to understand the recursive process. Okay? Okay, so if we take a look at this code here, we're going to actually analyze this together. Okay, so we have a main. We're going to call the right vertical method. Each individual use case that I listed before, and then here is obviously where the magic is going to happen. So what I'm going to do is I'm going to take this, we're going to copy it, and then we're going to trace through it step by step. So I'm going to first point you to this block of code here. Okay, so this is basically we can say the base case, right? So whenever we come across the number and it is a single digit, right, meaning it's less than 10, okay, we want to print it out, because remember, when we did right vertical, right, if we did right vertical 3, that's going to, so we'll use output here. For right vertical 3, we're going to do 3, right? That is a simple base case. But what if we had right vertical, say 1, 2, 3, right? We actually only want to write, so this is the first step. We want to write 1, then a new line, then 2, then a new line, and then 3, right? So every time that we print it out, right, we actually have to hit this system.out.print line. Okay? I hope you're still with me on that. Let me repeat that again. So if I'm going to put in, so this is, we can say this is n, right? 1, 2, 3, we need to print this out vertically, right? So if we look at the code, the section that is going to actually do the printing is when n is this, and this. But n starts out as 1, 2, 3. So we have to figure out a way to isolate each individual number. Okay, and we'll get to that, how we isolate it, right? But so we can call this the base case. Okay, so that the only time we print things out is when we have a number that is a single digit, which is, we can say that it's less than 9, right? So let's hold that thought, at least in terms of what you're looking at now. So this we can call is the base case. Okay, now comes the hard part, right? Now comes the part where we have to do a recursive call. Okay, now if you're looking at the function call now, let's actually do this one here. Let's do this function call. Okay, so if right vertical is called with 1, 2, 3, remember that n is going to be 1, 2, 3, right? 123, right? We come here, and is 123 less than 10? No. Okay, it's not. Okay, so we're good with that. We're not going to print anything out. We have to now, because it's not less than 10, we have to start isolating each individual one. So how do we do that? Well, what we can do is, how do I get the 1 out of this 1, 2, 3? Well, I can always divide 123 divided by 10, right? And if we do 123 divided by 10, we're going to get 12. Okay, so on the first call, this thing here is saying that we're going to make a recursive call to say n divided by 10, which is, remember, we have to do this first, right? So 123 divided by 10 is going to give you 12, right? And then we can do a recursive call to say right vertical 12. We still haven't isolated the 1 yet, but we'll get there. Okay, but we have to be patient. Okay, so now this is going to call right vertical of 12. Okay, and that means that now this over here, what is n? N is 12, right? N is 12. So now n is 12, and we're gonna do the same thing here, right? So this is on the first pass. On the second pass, now we have 12 divided by 10. And if we do 12 divided by 10, that is going to give you 1. Okay? That is going to give you 1, which means that because it's going to give you 1, again, this gets evaluated, right? We just evaluated n divided by 10. We're just basically, so we can say that this is n up here, right? Which means that we are saying right vertical of 1, right? So we're making another call. Okay. Now again, think of this as a kind of some type of stack. Okay, where you're piling these on top of each other. Okay, so we started initially with this call. Okay, then we came here, then we came here. Notice how nothing's been returned yet. Okay, nothing's been returned yet. So now when we do right vertical of 1, okay, and this is separate, right? So right vertical of 1, what does n become? Well, n becomes now 1, right? That's exactly what we wanted. We want to isolate 1. And we have our base case here, right? So is n less than 10? Yeah, it is, right? Because n is less than 10, then we print out the number 1, right? So this in itself printed out the number 1. Okay, and then this now, because there's no else, the function itself, this function call right here, gets popped off the stack. So we can kind of X this out. Okay, we X that out. Now, because this got popped, right, we're done with right vertical 1. What happened to the right vertical of 12 call? Well, remember when we went into right vertical of 12, we halted here, right? This is where we halted, which means that now we can continue because we just got popped from the previous function call, right? So remember, every time you go into a function call, the program, well, the function call itself halts. So until this function, the number 3 here, pops, we're still halted. Okay, because we popped, right, and we printed out 1, and that pretty much returned, right, means that now we're gonna go back and continue execution. Okay, which means that we are now over here, right? So now write system.out.print n modulus 10, right? N is 12, right? So 12 modulus 10 is what? It's going to be 2, right? Because 10 goes into 12 one time, and the remainder is 2, right? So that's going to print out, right? So this prints out over here. Okay, because we printed out over here, again, boom, we pop, right? There's, after we're going to continue execution, we pop. So this gets popped, right? And then we continue execution from where 1, 2, 3 left off, right? So this still needs to continue execution. Okay, and 1, 2, 3 modulus 10 is going to give you 3, right? So this is going to print out that because this thing here again is doing this over here, because the one that went after already popped, so we're going to continue execution. Okay, we got to continue execution on that. Okay, and that's pretty much the way that the flow of execution goes. So when we do a recursive call, that initial recursive call will first halt the caller, and then the caller will wait until it's done, and then once it's done and it pops, it will continue flow to the bottom. Okay, it'll continue flow to the bottom. So as you saw, remember here we did it twice, right? We did it twice. Okay, I'm gonna stop the video here, and then on the next video I'm gonna do an example where we do we'll do a longer one. Let's do 1, 2, 3, 4. Okay, and we can take a look at the code that way. So join me on the next video, and we can do one more example, and hopefully that should hopefully have you understand how the flow control flow works. I'll see you on the next video.